Hello, very good afternoon, all of you. So, today we'll understand about one topic of hydrology, which is estimation of missing rainfall data. So, if accidentally we miss some data to record from any of the rain gauge station, so what we can do is we can estimate the data of that day, right? But there are some requirements for it. So, for estimation of missing data, it can be because of some absence of observer or any instrumental failure, which may needs to use of this method. Now, let us suppose there are three rain gauge stations, which is being named as station 1, 2, and 3, and there is a station X for which we have missed the data for some day, and there are some more notations which I will be using in this uh, problem, in this topic. That is, what do you mean by N1, N2, and N3 or NX? What are these representations? So N1, N2, N3 are average rainfall, average annual rainfall. N1, N2, N3 are average annual rainfall, and P1, P2, P3. Next is P1, P2, P3, or any value Px is represent as precipitation data. Precipitation data. Right. Now there is a condition we can use to estimate the value of Px. We can use the technique. First is called as normal average method. This method is normal average technique. Of estimating the value of Px. Px is the station on which we have missed the recording at some day, right? So if N1, N2, N3 or it they doesn't differ within 10% of Nx, that means if the variation or difference is not more than 10% or less than 10%, you can use this normal average technique for estimating missing data. Right, I will do one example also. Now what if the difference is greater than 10%, then the method that we're going to use is called as weighted mean method. Weighted mean method. In weighted mean, what we are doing is we are estimating or calculating the value of missing station precipitation data, as like if there are three number of stations, so we are doing it for three, as P1 into Nx upon N1 plus P2 into Nx upon N2, P3 or Nx upon N3, where N1, N2, N3 are average annual rainfall. Or this method is suitable for when the difference between N1, N2, N3 from Nx is more than 10%. So if the difference is more than 10%, then we are going to use the technique which is being mentioned. Now there is one numerical in which some data is being provided to us. We'll read the question first. The precipitation station X was inoperative for a part of month during which a storm occurred. The respective storm total at three surrounding stations A, B, C. So we have been given the values of precipitation. Storm totals is precipitation. So we can take it as P1 or PA. PA is being given as 107 mm. PB is given as 89 mm, and rainfall data for PC station. C station is being given as 122 mm, right? And we have to calculate PX. So on X station. So average annual rainfall is also being given. Average annual precipitation amount station for X, it is given as 978. For A, it is being given as, so we are writing as NX NA, average annual precipitation 978 mm and 1120 mm. Then we have been given as value NB as 935 and NC as 1200 mm. So first of all, the examiner wants us to check whether this average annual rainfall data, which is being given to us as NX, NA, NB and NC. So if it differs more than 10%, then we'll go for the second weighted mean method, and if it is less than 10%, then we'll go for the normal mean method, right? So we'll check. So for that, what we'll do is we'll calculate 10% of NX value. So 10% of NX, that means 10% of 978 mm. So 10% of 978 mm will be 97.8 mm, right? And if we'll add the value to check it from other stations like NX, when it is being compared with other stations, so like we are getting it as for NX, the difference is like 978 plus 97.8 mm will be equal to approximately 1075.8 mm, right? Which is less than 1120 mm. That when it is being compared with NA, NA and NC, it is less than 1120 and less than 1200 mm. So that means difference in NX and the for other two stations is more than 10%. So we'll go for weighted average method, weighted mean average method. So which says that, I'm writing the equation once again, Px is equal to 1 by 3 P1 into Nx upon N1 plus P2 into Nx upon N2 plus P3 into Nx upon N3. Now for this case, two stations are being given as PA, PB and PC. So we'll put the values as 1 by 3 for PA. Precipitation at A station we have been given 107. NX value is 978 divided by N1 is 1120 plus P2 value is being given as 89. NX value is given as 978 divided by 935. plus 122 978 divided by 1200 mm. So for this you'll get you can calculate, and you'll get it as 1 by 3 as 93.5 plus 93.1 plus 99.4 equal to 1 by 3 into 286. We'll get the answer as 95.3 mm. This is the precipitation value at station X, the data that we have missed. So missing precipitation data at station X is 95.3 mm. Thank you so much.